Hello everyone, I'm Ting Su from East China Normal University in China. I will introduce our work, fully automated functional fuzzing of Android apps for detecting non-crashing logical bugs. This work was mainly conducted when I was a postdoc at ETH Zurich in the group of Professor Zheng Su. This work is jointly conducted with Yi Chenyan, Jinling Sun, Yiheng Xiong, Ge Guangpu from East China Normal University, Xue Wang from Nanjing University, Ke Wang from Visa Research, and Zheng Dongsu from ETH Zurich. As we all know, mobile apps are now ubiquitous. Take Android apps as an example on Google Play, there are over 3 million apps. However, according to a recent consumer survey, it shows that the issues are common for mobile apps. Around 56% respondents replied that they have had problems with mobile apps within the last 6 months. Among these problems, 62% issues are related to crash bugs. 37% issues are related to non-crashing functional bugs. We can imagine that telling whether an app has experienced a functional error is hard because it requires human inspection. Therefore, how to automatically finding non-crashing logical bugs is a challenging problem. Unfortunately, existing solutions do not work well to tackle this problem. For example, manual testing is expensive, small scale, and lack of automation. Human testers have to manually write UI tests and oracles. On the other hand, modern fully automated GUI testing tools are limited to crash bugs because they are lack of test oracles. Static program analysis tools are also difficult to find app-specific, non-crashing logical bugs. In this work, we tackle this hard problem by proposing a fully automated functional fuzzing approach, which we call independent view fuzzing. Given an app, our approach automatically detects non-crashing bugs without requiring human-provided tests and oracles, and the detected bugs are diverse and not limited to specific functional properties. We implemented our approach in a tool named Genie. Genie successfully found 34 non-crashing bugs in each of the 12 evaluated apps. Note that none of these bugs can be automatically found by prior testing tools. Before I start to illustrate our approach, I present a real non-crashing bug in App Activity Diary, which is a simple diary app for recording one's daily activities. Let me first show you a normal use scenario of this app. We first start the app on the Startup page. At top, the app shows the current activity. When no activity is selected, it shows no activity. At the bottom, the app shows a list of available activities for the user to choose. Next, when we click Office Work, the current activity becomes Office Work. Then we click the camera button. We can take a picture to describe Office Work. Then we can navigate to the History Activity page. Here, we can see the recorded activity Office Work and its picture. If we long touch on the picture and choose OK to delete the picture, the Office Works picture can be correctly deleted. However, there is a functional bug which resides in this functionality. As before, we first start the app, click Office Work, and then click the camera button to take a picture. At this time, if we click Cooking, another activity, the current activity will switch from Office Work to Cooking. We can also take a picture for cooking and then navigate to the history page of all the recorded activities. On the history page, we now can see two activities, that is cooking and Office Work. Now, when we do the same thing as we did before, we long touch the Office Works picture and try to delete the picture. We will finally run into a buggy scenario. The cooking's picture is erroneously deleted, and Office Works picture is still there. This bug was only noticed and reported by an end user. The developer responded that this is actually a heavy bug. Our approach can automatically detect this bug because it leverages a commonly held property we observed in Android apps. We name this property as independent view property. We find many apps hold this property, that is, interacting with one GUI view does not affect the states of others and only adds but not remove additional GUI effects. Let me give an intuitive example to illustrate what the independent view property is. So here, I show the subtrace of prior usage scenario of activity diary app. We click office work, take a picture for it, click cooking, take a picture for it. Here, it is obvious that office work and cooking are the two functional independent views because they are two independent options in a list view. That is, interacting with office work, of course, should not affect the status of cooking. We named such property as independent view property, and such views are independent views. And these two subtraces starting with two respective independent views are independent event traces. Here, scenario 1 shows the pages from the normal usage scenario I introduced before. Scenario 2 shows the expected normal behavior when we additionally start cooking activity and take a picture for it. We can see by adding an independent event trace into the first scenario, the original GUI effects are kept same, and only a new activity cooking and its picture are added. Thus, inspired by metamorphic testing, our key insight is, given a seed test, we inject independent event traces to generate mutant tests and execute the generated mutant test to check the GUI effects before and after the insertion position. Now let me illustrate the workflow of our approach step by step. In the first step, Genie will automatically mine a transitional model to capture the app behaviors. For example, Genie can mine such a partial transitional model of app activity diary according to the normal usage scenario introduced before. If we continue to explore the app, we can include more GUI states and events and thus get a more complete GUI transitional model. In the second step, Genie will infer independent views during the execution of seed test. Here, we assume Genie gets a seed test which corresponds to the normal usage scenario introduced before. Specifically, during the execution of this seed test, Genie will analyze which views have been executed and annotate them as active views and also update this active view information across the following GUI pages if possible. According to the active view information maintained on each GUI page, Genie will analyze which views are inactive and independent from the current active view, by which we can inject independent event traces. In the third step, Genie generates the mutant test from a seed test. For this seed test, when Genie chooses L3 as the pivot GUI page, it will inject one independent event trace, L3 U1, which denotes clicking the cooking and taking a picture for cooking. This trace is independent from the preceding subtrace L1, L2, which operates on the view office work. You may be curious about how Genie can find such an independent event trace. In fact, Genie queries the transitional model to find such an independent trace. In this way, the generated mutant will be dynamically executed on Android devices to generate the concrete mutant test. In the fourth step, Genie will do automated oracle checking based on the independent view property. At the high level, it computes the GUI effects from the seed test and compare with the corresponding GUI effect from the mutant test. If the GUI effects from the seed test are not held in those of the mutant test, Genie reports a likely bug. In the example bug, we compute the GUI effects between L4 and L6 in the seed test, and the GUI effects between L4 prime and L6 prime in the mutant test. We can see the GUI effect in the seed test is the deletion of office work's picture, while the GUI effect in the mutant test is the deletion of cooking's picture. Obviously, the independent view property is violated. Thus, Genie catches this bug. To evaluate the effectiveness of Genie, we answered the 4 research questions. In this talk, I will focus on the first research question and the fourth research question. In the first research question, we investigate can Genie automatically find non-crashing functional bugs in real-world apps. In the fourth research question, we investigate what types or characteristics of non-crashing bugs can Genie find. In the evaluation setup, we choose 12 real-world Android apps as the target apps. Specifically, these 12 apps have diverse app categories and have been actively maintained for a long time, and they are real-world and popular on Google Play and GitHub. And we tested the latest release versions of these apps. For these 12 apps, Genie is able to find non-crash functional bugs in each of the 12 apps. As a byproduct of our testing, Genie also found some crash bugs. In total, Genie found 34 non-crashing bugs, all of which have been confirmed and 22 were already fixed. The bugs found by Genie are diverse. We are able to categorize these bugs into 6 different categories, including user data or setting lost, function cannot proceed, etc. This page illustrates some bugs found by Genie. For example, this bug was found in SkyTube, which is a video player. Users cannot play the video anymore if they open the video in a browser and return back to the internal player. This bug was found in Activity Diary. When users undo an irrelevant activity, the app will jump to an incorrect active page. Some bugs are manifested as duplicate views or disappeared views. This figure characterizes the 34 bugs found by Genie. Here, each blue point denotes a bug. The x-axis denotes the number of months of bug existence in the apps, and the y-axis denotes the affected release versions of the apps. We find 26 bugs were unnoticed for more than 1 year, and 19 bugs affect more than 10 app releases. It clearly indicates Genie can indeed help find non-trivial, non-crashing functional bugs. To wrap up in this talk, I introduced that automatically finding non-crashing functional bugs is a challenging problem. To tackle this hard problem, we introduced independent review fuzzing. Our implementation Genie is open sourced to benefit the future research in this direction. In fact, we have made continuous efforts in the past few years to improve automated GUI testing of Android apps. We have proposed STOT, a guided stochastic model-based GUI testing technique. It aims to effectively find deep crash bugs. In the following, we propose themes to benchmark automated GUI testing for Android apps against real-world bugs. We obtained many previous unknown insights to further improve existing tools. We propose SetDroid, which is a fully automated setting-wise metamorphic fuzzing technique to uncover system setting-related issues in Android apps. Such issues are very hard to be found by existing GUI testing tools. In this talk, we proposed Genie. All of our tools have been made public available to benefit the community in this field. Feel free to download and try them. During this journey, we also contribute to many commercial apps by helping them finding non-trivial crash and non-crashing bugs. Okay, thank you for the listening. I'm now ready for taking any questions.